It's working cool. Thanks for having me, everyone. That was a really cool talk. Hopefully I can match that, but Patrick just did describe this talk as my depressing talk about the web, so forewarned. But anyway, thanks for having me and to talk to you about something which kind of means a lot to me and which we work out a lot at BuzzFeed, which is building resilient front-end systems. And this kind of pushes the boundaries of what classifies as front-end development. But one thing I figured out is that the only people who are going to care about this stuff are the front-end developers who push for this kind of stuff, so it's important that we all know about it, even though it's not a core concept. So I work at BuzzFeed, where there is an article for absolutely everything. And I worked there about 2 years, and I lead the front-end infrastructure team. And this talk is kind of the story of our road to resilience, because when I first joined, we were in not a great state, and we learned through trial and tribulation how to become a bit more resilient. So a lot of those lessons that we learned, hopefully I can just quickly give to all of you, and you don't have to go through those same processes. And hopefully at the end of this talk, this is the question you go back and ask yourselves about your systems and your products. How resilient are they to failure? And what do we mean by resilience? So resilience is function in a hostile environment. And this is super important for us as front-end developers because the browser is a very hostile environment. You know, we have no guarantees, or we have very few guarantees. We have no guarantees over the runtime, like that people have different browsers with different APIs available. We don't have any control over the amount of resources available to us because we are on different devices. And also, we don't ship a compiled product, right? We sort of assemble our products on the fly through a multitude of different network requests. And if they all go to plan, we might be in a good state, but that's not always the case. So the way we think about resilience at BuzzFeed, and the way I think we should all be sort of thinking about our systems, which is not a new way of thinking, is about understanding our tiers of user experience. So there is the ideal user experience, the perfect way that your app can be viewed, and that's often the thing that we develop on. So it's, you know, Wi-Fi, Big Mac, all that kind of stuff. And then there's a super basic experience. What happens what's the least amount of functionality you have to have for you to consider it to be working? And very likely there are many tiers in between where you can layer on functionality in a progressively enhanced way. So to be resilient, we need to be able to guarantee this most basic level of user experience. That's kind of it. If we can guarantee that, then we have a resilient website, we have a resilient product. So in this talk, I'm going to go through 4 things, really. So how our systems can fail, lots of the many ways that happens. How we can actually design for that failure, rather than shying away from it. Some ways that we can mitigate the risk of failure happening at all. And then finally, how we can learn from these failures. Because regardless of all this effort we put into making it resilient, it's inevitable that more failure is going to happen, so we might as well learn. All right, so how can our systems fail? Turns out there's quite a lot. So the first one is malicious interference. And what I mean by this really is an external person tampering with your product, your system, your resources in a certain way. So for you to have a resilient website, HTTPS is table stakes. You can't be in the game unless you have a secure way of delivering your content, because you can't guarantee that basic level user experience. If you can't guarantee that someone hasn't tampered with the data and the information that you're trying to send to your users. But it doesn't stop there. Even if you are requesting everything over HTTPS, things can very easily be interfered with. There was this great example recently where a script that a lot of government websites were using, not just in the UK, but in the US as well and in Australia, we're running a script which was designed to add speech and reading and translation to websites. You know, a noble cause. But someone had actually interfered with that resource at the far end, nothing to do with these particular websites. And they injected some malicious code in there, which is very hard to spot, and that ended up installing crypto mining code on our users' software. And the reason this happened is because we gave trust to this third-party resource. But the sort of management system, I'm sure when this happened, did not really care about that trust system. They were thinking, why did this happen? Why weren't we in a better position? And when you give someone access to put scripts on your page, you're basically giving them free rein to do whatever it is they want, and you need that trust. But it doesn't stop at just scripts either. One thing we're quite concerned about, or we were concerned about at BuzzFeed, is images. So we use a third-party image service to resize and to crop and alter our images. And if someone had maliciously interfered with that service and returned not safe for work images or graphic images, we would really have no control over that, except to switch it off. So we have to build in ways to mitigate that risk. Basically, trust people. Pick your third parties and trust them well. And then make sure they're available. This is the second way, and often one of the more catastrophic ways that our systems can fail is third-party availability. Like, we all need third parties. We don't want to invent everything in-house. We need to rely on the work of other people. But when these things do go down, it's usually us that has to pick up the pieces and wonder why our services aren't working. And a lot of the services we do rely on, like, they'll give you SLAs to say that we'll have 99.99% uptime. And one thing I've learned from my experience working with these things is that that's not really a guarantee. That's just a reflection of the past and not a predictor of the future. So I just no longer trust nines in any way. So an example of this in a very sort of straightforward way is just a script that we put on our pages, and it goes to some thirdparty.com. And we're giving this third-party website rights to execute whatever it wants on our page. And if it's unavailable, then our page will have either total or partial failure in some ways. And they're pretty obvious to spot. You can see them a mile away. But a lot of them are less clear. This is kind of a direct third party, but some are a bit more abstract. So taking it back a little bit, I joined BuzzFeed in 2016, and just after that, everything started breaking, which I'm only going to take some of the credit for. But the first thing that happened quite soon after is Dyn, which is a DNS provider, suffered a distributed denial of service attack. And we didn't rely directly on Dyn, but a lot of our third parties did rely on Dyn. And this was affected for about 5 hours, and BuzzFeed had some partial availability throughout this time, and it was kind of stressful. Fast forward a little bit, AWS S3 went down. Anybody here affected by that outage back in the day? A few hands, yeah. That was fun. So we weren't as prepared as we wanted to be for that situation. We had a lot of old systems that we were trying to migrate over. And this was something that everyone kind of just didn't expect. Everyone says S3 doesn't go down, right? That's a thing. We can trust that. That's not going anywhere. It did, and it affected us. We then fixed a few things, and Fastly, our gold sponsor, had a tiny availability issue, but it was for about 10 minutes on their East Coast cache went down, and well, it didn't go down, it just dropped its cache. And so it flooded our systems with requests for about 10 minutes. But as we just deployed these brand new systems, we were hoping that wouldn't happen. And obviously, it inevitably did. And so for about an hour, we were affected. And then just to add insult to injury, S3 went down again for a couple of hours. This time, thankfully, we're in a better position. Don't trust third parties. All right, what's another way that things can fail? Well, we can break it. Developer errors is going to happen. And we talk about this, we're talking about runtime errors happening. Because obviously we all have tests, we have great tests, that's cool. But our tests kind of test things in our nice and controlled environment where networks are available and all this kind of stuff, and we choose our base browser that we test on, or browsers. And actually, the errors happen in reality past all the tests. So you have to have some kind of production monitoring. For exceptions, we use a tool called Sentry, which is a great way of handling and triaging errors, and a good way of catching these exceptions. But it's not a good way of getting them fixed, because people don't go and look at dashboards where things break. So you have to sort of send those errors to where people are, which for us is Slack. So this is quite tricky, actually, figuring out the signal-to-noise ratio of when you can bother developers when something is big enough of an issue. You get better over time. But BuzzFeed has some pretty engaged users who like to tell us things. And for us, the way we think about this is just knowing it's broken before Twitter does. Before the hordes come in and everything's broken, guys. And we have these post-mortems after big incidents, and this is the thing that I'm always the most interested in. It's how did we find out that things were broken? Did we find out, or did someone on Twitter tell us? But it happens. I'll tell you a story about a bug that I shipped, of many, which was something to do with our images. So we were rolling out something called shielding, which is a Fastly product, kind of service, to give us a better hit rate on our images. And this affected how we were doing content negotiations, so we were serving WebP to certain people and JPEGs, et cetera, to others. So we shipped this fix, this image shielding fix, and because it was affecting WebP, I opened up Chrome. Great, images working fine. Good job, everybody. And then suddenly afterwards, everyone was like, oh, all the images are broken in Safari, because we didn't really check it. And this was across everything that BuzzFeed owns. So quickly rolled that back, and then we were like, well, why didn't we know about this? Why didn't it show up? And of course, when an image doesn't load, it's not really an exception. It doesn't show up in Sentry, it's just an event. And we realized we didn't actually have this observability that we needed to understand that the experience is broken. Because a lot of our pages, they don't even work if you have images. They kind of work, but the context is in the image. So we built a little system which allows us to understand this better. It's really simple, but when an image fails to load, it pings a service, and we can graph it. And then the graph looks something like this. And there's errors happening constantly. They trickle along. But sometimes they spike, and then we know that something has broken. But the interesting thing about this, for me, was we now had this system that we made out of the necessity, but that allows us to understand the true user experience that's actually happening at any given time. So another way that things can fail is the network. So this is something we heard many times in many talks. The network is flaky. But it's not something I've ever validated myself, how good, how bad it is actually the network. One second. I trusted all those blog posts, obviously, but it's still nice to see it. But now we had this system. So we extended it a little bit, and we turned it into this, which tracks things like when JavaScript fails to load, fonts fail to load, images fail to load, etc. And this is really useful for us because if something breaks, we find out pretty fast, and it's actually the user experience that's breaking. It's not just some internal metrics. It's not great for communicating with people outside of our teams, so we flipped this into something a little bit more readable. This is based on an hour, so these are a little bit low. But ultimately, we realized that failure is happening constantly, and we have no control over this. And some of the top-line figures are the fact that around 1% of our requests for JavaScript will time out. This is the part where I test that you were paying attention during Bruce's talk earlier. Because, yes, 13 million requests for JavaScript will time out every month on BuzzFeed.com. And this number has become a little bit mundane because, as I've been looking at these slides longer and longer. But the first time I saw this, I was pretty blown away. We support IE11, which is less than 1%. And if we choose not to support this, what decision are we really making there? There's 13 million potentially broken experiences if we rely on JavaScript for there to be an experience. So this starts to become a communication tool for how we build our systems out. Okay, but let's say all this thing is fine, right? So no one's interfered with anything. All the third parties are 100% available. We've not written any bugs, of course. And the network is flying. We should be fine, right? Well, there is still number 5, which is the user's privilege. around 9% of our users use some form of content blocker. Mostly to block ads, but these things can be very unpredictable and can actually have like far-reaching effects on your code and your product in ways that you don't anticipate. I used to work on a CMS for advertising. Ad blockers would just rip bits out of the DOM left, right, and center if you ever use a class name with the word ad in it. So, these things aren't guaranteed. And they're content blockers, they're not ad blockers. So we see that around 4% won't successfully get our fonts. And if we know that roughly 1% of these network requests are going to fail, then there's around a 4x increase there. So this is 40 million page views a month there without fonts. And this is good for design to see and to understand that actually maybe it's worth investing in how it looks a little bit, or maybe not, but at least let's not sort of throw icons inside our fonts if they're crucial to the UI and to the actual experience. All right, so yeah, loads of ways that things can fail. What do we do? Well, we can hope for the best. And I'm only like slightly flippant with this. I actually think that a lot of the time this is fine. Right? Most of your systems don't need to be 100% available. Like, a lot of them can be internal tools or just like side projects, whatever it might be, it's not important. But if you support loads of client websites and they're all going to be on the phone to you if something goes down, or if you work for a company, perhaps on an e-commerce, where a lot of your revenue for the entire year comes in a small window, maybe in the holiday season or Black Friday or whatever, and then AWS goes down, then one of your image servers go down, that's not where you want to be. You don't want to be getting that phone call. And for us, we can roughly quantify the cost per minute of BuzzFeed being down in terms of our revenue. And once you can do that, you can start to calculate sort of the actual cost of these failures happening. So you could hope for the best, or you could start to design for failure. Rather than hoping for the best and hoping that failure doesn't happen, just accept that it's going to happen. We've proved that it's going to happen constantly, and start to own it and work your system around that as a constant. And the ways that we do this are not novel or new or anything that people who've been preaching progressive enhancement for a long time wouldn't have told us many times. The first way we do it is we just prioritize these critical parts of the page. So if we look at maybe like a typical dependency graph for a website, sorry if this is washed out, but we have CSS, JavaScript, images, which request more assets, which might be required to have an experience. And if the experience is ready when we get to the bottom of this graph, rather than at the top of this graph, then every single arrow here is a point of failure, a potential point of failure. So if it's right at the bottom, there's so many more ways in which this system can fail, can break down, and that your user experience will be broken. Ideally, you want to get a working user experience in this first request. Then you have just one point of failure. And I think that any website can accomplish this. This doesn't mean that it's going to be a fully working user experience or a fantastic experience, but it's something. So this is the article page on BuzzFeed. And the thing that we care about on this page is, unsurprisingly, this bit, right? The actual article. We don't really care about the thumb strip at the top or the right rail or the ads. Well, we care about the ads. But it's the article. So if everything except that first request fails for us, the page looks like this. And it's not going to win any design awards, but you can start to engage with it. You can start to read it. You can start to understand it. This is maybe simple for a read-only site. We don't have back and forth. But I do really think that it's achievable. It's about prioritization. If we take a look at another site, the train line, which is more of the other side, they don't really care too much about you consuming this page. They want you to actually interact with this form over here. And that form probably requires a bunch of JavaScript and is very nicely built. But there's no reason we can't make it work without all those things. And there's no reason we can't inline certain little bits of helper, CSS, JavaScript, to make that a working experience without those subsequent network requests. Another way which we can design for failure is by really making these errors a first-class citizen. Really start to think about the user experience. And this isn't necessarily thinking about how these errors might look or like the designing of these messaging. For us, the way we think about it is like something broke, right? This happens. Like, should I tell them? Do I have to tell the user that something broke? And if so, how do I tell them? Can they do anything about it? So on this page, again, we have this BuzzFeed News link module on the right-hand side over here. And let's say this breaks, because this is requested wholly independent from the rest of the page and comes in separately. If this thing doesn't work because of network request failures or just because the actual system that powers this is down, do we have to tell the user? Like, do you think they care? Or can we just slide that up and pretend nothing happened? Like, for us, we care as developers, and we should be pinging metrics back constantly there. But only some very, very avid users of BuzzFeed will actually notice this. Conversely, this is our CMS for BuzzFeed, which is fully public, by the way. Anyone can go and make articles, which is terrifying from a security perspective, but we'll fix that. But yeah, if publishing here fails, we can't just pretend nothing happened, right? We can start to think about how to design that state instead. And maybe that looks something like this, where we say, we're going to save all your data locally, and we're going to be very, very transparent about how things are working. There are ways to design around these constants rather than avoiding them. But if we can avoid them, even better, right? Which is another part of this talk I want to talk about, like mitigating the risk of any of this stuff happening in the first place. We talked about like how to handle errors, how to deal with it, but why not just avoid them? So the first way we can mitigate risk is just to lock our runtime dependencies. So we have all these non-guarantees on the web. And if we can't guarantee that our own code is the same every single time, things get even harder. We've got to give ourselves something to stand on. So when we look at this kind of thing, again, there's some thirdparty.com/main.js, there's no real way of us to version that and to lock it down and to guarantee that it doesn't change. We can put a version number in the URL, but for all intents and purposes, that is irrelevant. Like, someone can just change the code at the far end, and we'll just arbitrarily execute it. Thankfully, we have a new thing in CSP, which is this integrity hash, which will allow us to say that if the resource that comes back doesn't match this hash, then we just won't execute it. And this guarantees that we're in this situation. It introduces a few other things, so if they change it, your website breaks. And they can't easily push updates out to you, which might be security updates, which you might want. So you have to build in that process for how you're going to update these things. But we're moving more towards this way of thinking where we want to make sure that our experience is the same each time. Another way, and one that we try and do a lot of as much as we can, is to build in redundancy for all our systems. In simplified terms, this is just, have two of everything. And this is, to actually begin the process of thinking about this, is you have to first audit all your third parties and all your first parties, and then think about where your vulnerabilities are. So let's just talk about S3 for some reason. Let's pretend that we have this asset server, an unbranded asset server up here. And we make a request to this server, but unfortunately, the server is on fire. Well, that server can't return anything, so we just stick with a white page, and our experience is broken. In a redundant system, we have a secondary asset server. And then we make a request to that one can return some CSS, and then we can paint a page. This is an active-inactive redundant system. The reason we call it that is because the asset server number 1 is getting 100% of the traffic until something goes wrong. And then we flip over to asset server 2, which is pretty good. It's better to have this than nothing for sure. But there's a couple of limitations to an active-inactive system. The first is that it usually requires some kind of human decision point where you say, I'm going to switch over. You can automate that, but for the most part, there's I'm going to flick a switch, and we're going to jump over. But the more pressing part of the problem with here is that we're not really testing the second server at all, ever, until we have to switch it on. And that can be kind of scary. Like if your first server is running at 60% availability, do you have the confidence to switch over to something that you've never run in production before? Yeah, I don't know. Much better to have an active system, which is what we have for our assets now. So instead of making a request to server 1 or server 2, we make a request to just server. And that proxies half the request to the first one, half the request to the second one, and then it returns some CSS. And this will be constantly testing both systems and returning at the same time. So one of these can set on fire, and for the most part, we're going to be OK. And we can apply this model to pretty much everything, whether it be image services. Maybe you have an A/B testing service, which if that goes down, your page doesn't render correctly, or whatever it might be. You can even expose this, take this sort of model and apply it to your entire cloud infrastructure, your CDN, your DNS. We took it to a little bit of an extreme with something called Plan Z, which is like a completely static copy of our entire website, which sits in S3 and GCS and is updated every couple of minutes. So that if AWS and everything just sets on fire, we can switch at the DNS level and point to the static version. That's kind of extreme, but actually if you already have a static website that's statically generated, maybe on Netlify, whatever it might be, you can do this kind of thing very, very easily. So redundancy is good. It saves you. So is serving stale content. So stale content we can define as something which does not come directly from your servers. It comes from an intermediary. And we can demonstrate that with a CDN. So in this case, we make a request to the CDN. That makes a request to our server. And it comes back with the resource, but also comes back with some asset. There will be some headers, and it says, cache this for 24 hours, whatever. And then we return that to the user. And the next time that we come back, it doesn't have to go to our server. This is not novel, and I'm sure all of you are very aware of this kind of stuff. However, there's other benefits we can have here. So we can send back other headers which say that even if the cache has expired, but we happen to be on fire, just keep serving it anyway. And this is our stale and error header. And this is good because we're keeping the user experience going. But actually, the other really, really important part of this is that it gives you time to think when things are on fire. It gives you that breathing space to make decisions which are best for your systems, because typically when things are on fire, it's quite stressful. We find that stale and error is a huge lifesaver in this situation. But what if this first request doesn't even work, right? We know that 99% will go through, but some will fail. Well, we can use a service worker as another intermediary, and we can consider this as a way to serve stale content. And it's not going to have the full cache that a CDN might have, but you can do something with it. Maybe you can serve the same article, or one of the techniques that we just saw before. Maybe it's just a nice GIF or a quiz. I'm not going to go more into that, but there's obviously lots of content out there on service workers. So finally, I just want to touch on how to learn from these mistakes and how to plan ahead in terms of learning. Because all the things we've just learned there, which we've learned painfully over years at BuzzFeed, they're going to happen again. There are third parties we haven't realized we have yet, or dependencies we haven't really thought we have yet. So if mistakes are going to happen, we have to learn from them. The main thing we can do is run postmortems, and run them religiously. Even if it's a small incident, take time after the incident to really get together and understand what happened. The most important thing about postmortems is that they're blameless. When S3 went down, it was because a single person inputted a command incorrectly into a system. But it was not that person's fault that S3 went down, right? If the system can allow that kind of failure to happen because of a manual command, then the system is at fault. And when you can start to think about it from that perspective, then it allows you to have a much better conversation and discussion about incidents and about how we react to them. So we want to talk instead about how did we handle it as a team? Was everyone available? Were the right people with the right knowledge in the right place? Was there documentation? Was everyone awake? That can often be a problem. And how could it have been prevented? When the post-mortem after the S3 situation, the incident lasted 9 hours, the post-mortem lasted 3 hours, and there was 30 actions we took away from that. And the second time it went down, my pager never went off, nothing went wrong. There was no user experience issues because we'd taken this time and gone through this process. And another way that we can be proactive about learning is to run fire drills and consider chaos testing. So as I said, these incidents are pretty stressful. It's not something you can easily get used to unless you're put in that situation. But fire drills are a safe way for us to practice this. Just simulating error and practicing how to respond to it. You can test these new sets of skills that we're not really designed to work with. Chaos testing is just fire drills, but with real fire. And you essentially deliberately introduce failure into your systems to make sure they're resilient. And if you're constantly introducing this failure, then when it actually happens, what's the difference, right? This is something that Netflix pioneered with a tool called Chaos Monkey, which brought down EC2 instances. But there are many ways in which we can do this and different ways that we can pull down things that we depend on to see how our system responds to it. So that's kind of a lot of information, but in summary, understand your product and know what's important to your users. Which is the things that you have to prioritize on your page, and which are the things that have to be working at all times. Identify how your system will degrade if other things are not available. Identify these points of failure, particularly any single points of failure, and build in fail-safes for them and redundant systems. And then just make sure you take the time to learn from every single failure. Really embrace this understanding of the fact that failure is going to happen. It's not a bad thing. The only bad thing is if we don't actually learn from it. Thank you.